This video is about scatter plots, or also called line of best fit. And so we'll go over scatter plot. The scatter plot is basically a plot of a bunch of dots. Okay, they're scattered about. And then when it comes to scatter plot and they talk about the line of best fit, that just means what line can we draw where we get the most amount of points in there. So this question says, which equation best represents the line of best fit for this scatter plot? So we want to see which one of these equations, if we were to draw it on here, would get the most amount of points, or little dots here, scatter plots. So I'm going to do each one and we can decide. Okay, so A, I'm going to make black. The equation is y equals 4x minus 4. So we'd start at -4 because that is our y-intercept, and our slope is 4 over 1. So we're going to count up 4 boxes. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, and that would be that line. Okay, now we're going to do the next one. I'll do that one in red. Okay, that's y equals 4x minus 2, so we're going to start at -2. We're going to go up 1, 2, 3, 4 boxes over 1. 1, 2, 3, 4 boxes over 1. Okay, we'll do that line. Okay, the next one we will do green. Y equals x minus 4, so this y-intercept is -4 again, but our slope is 1 over 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay. Okay, that line looks like that. And then the last one, I guess we'll do maybe blue. Okay. And that's y equals x minus 2. So we start at -2. And our slope is 1. So we're going to go up 1 box over 1 box. Up 1 over 1. Up 1 over 1. Up 1 over 1. Okay. And draw that line. Okay. So we have our 4 lines. So which one is the best fit? Which one gets the most amount of data? Okay, if we take these away, we can see that this green line definitely is in the data. So the answer is C. Okay, so that's just what a line of best fit is. Which line, if you were to graph it, gets the most amount of points? Okay, the next one says, Jane recorded the score she received on tests compared with the numbers of hours she watched television on the nights before the test. So we have her test score and how many hours of television she watched the night before. What does a scatter plot imply about the relationship between her test scores and the number of hours of television she watched the night before? Does it imply that Jane's grades are going down? Jane will never watch more than 4 hours of television? Getting higher grades will cause Jane to watch less television, or Jane's lower grades tend to follow nights where she watched more television. Okay, and the answer is D. The more television she watched, the worse she did on her tests. Okay, the next one. Tamara recorded the population of Medville for certain years in this table. So you have the Medville population, years, and then the population. She determined the line of best fit that models this data is y equals 18x plus 1,520, where x represents the number of years since 1985. That's a key word here, since. And y represents the population. According to Tamara's models, what is the best prediction of the model of the population in Medville in 1997? So your dates or your years are your x's, and your population, what you're getting out, is the y's. So all we have to do is pop this in for x, and then it'll spit out our population. But the key here is they said since 1985. So the first thing you need to do is take 1997, subtract 1985. and that gives us 12. So our x equals 12 that we're going to put into the equation. Okay, so this, thinking back on that scatter plot in the first one we went over, so we have all these points that are on there, and then she comes up with a line that best gets all of those points, and this is the equation for that line. Using this equation that tries to get all the points, what would we think the population would be in 1997? Okay, but this is since 1985. So we need to do 1997 minus 1985 and then pop that in. So 18 times 12 plus 1,520. Okay, 18 times 12 plus 1,520 equals 1736. So the answer is C. Which of the scatter plots is described by the line of best fit of the equation y equals negative 2x plus 1? Okay, so this is our starting point, our y-intercept at positive 1, and our slope is negative. So remember, negative lines look like this. So we can already get rid of 2 of your answers based off of we know it needs to look like this. We can get rid of F because that's a positive line, and we can get rid of J because that is also a positive line. So now we're in G and H. So let's graph this equation on both of these scatter plots and see which one works the best. So this one is at 1, okay, and then negative 2, so we're going to go up 2 over 1, up 2 over 1. And also go down 2 over 1, down 2 over 1. Okay, so those red dots are this line. And then we're going to do the same thing here. We start here. It's our y-intercept. We're going to go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. Okay, so which one do we think this equation goes to? Does it go to these dots or these dots? Right, it goes to this one. Okay, almost always when you're dealing with graphs on the EOI, you can get rid of 2 of them based off of positive and negative. And then it gives you a 50-50 chance. Okay, a line of best fit has been drawn on this scatter plot. Which equation represents the line of best fit for the scatter plot? Okay, is that a negative line or a positive line? Right, it's a negative line. So I can already get rid of A and B. Okay, so now I'm down to C and D. They have the same slope, but they have different y-intercepts. So is the y-intercept where it crosses the y-axis? I know you don't only see one quadrant, so don't forget that these numbers right here are where the line crosses the y-axis. Okay, even when we just have one quadrant. Okay, so does it cross the y-axis, at 13 over 2 or at negative 7? Okay, 13 over 2 is just 6.5, or does it cross at negative 7? Okay, it crosses at positive 6.5. So we know the answer is C. See, you didn't even have to know that much. Okay, we got rid of 2 answers because this is a negative, and then the difference between our equations was the y-intercept. 6.5 positive or negative 7? It's 6.5. The table shows the number of calories John burns while riding his bicycle. So we have how fast he goes and how many calories then he burns. John determined that the line of best fit for this data is y equals 68x minus 272. If his speed is a constant 16 miles per hour, how many calories can he expect to burn when he rides his bicycle for 5 hours? Okay, so this is kind of a two-part. So he's going 16 miles per hour constant. So we need to find out how many calories he burns for an hour, but then he's doing it for 5 hours. So then we need to multiply that answer by 5. Okay, so let's find out how many calories he's burning if he's riding his bicycle at 16 miles per hour. Okay, 68 times 16 is 1088 minus 272. Okay, it's 816. Okay, which of course is an option. They're trying to trick you. Okay, so going 1 hour at 16 miles per hour is burning 816 calories. But they want to know if he rides his bicycle for 5 hours. Then we're going to multiply this times 5. And that's 4,008 calories. That is a lot of calories. Okay, so just make sure you read the whole question several times. Make sure you know exactly what they're asking for. Just take your time. Which of these equations represents the line of best fit for this data in the scatter plot? Okay, we see a graph. Of course, 2 answers are negative, 2 answers are positive. So, is this a negative line or a positive line? Correct, it's negative. So we can get rid of C and D. So now we have the differences between these two equations is -2 for the slope or -1/2. Okay, since there's no B here, we have y equals, mx plus b, where b is where we start, or the y-intercept, and m is our slope. Since there's no b, that means we start at the origin, or at 0, 0. Okay, so are we going up 2 over 1, which would be the first equation. Okay, so did that one in red. Or are we going up 1 over 2? Up 1 over 2, up 1 over 2. Which one looks like a better fit for the data? It is B. Okay, that one fits the data, gets the most amount of points. The graph shows Jason manufacturing weekly profits over the last 2 months. What is the best prediction for their profits in week 10? Okay, so we have an upward trend. So week 10, do we think it would be 20,000? That doesn't really make sense. That doesn't fit with the rest of the data. Okay, 22,000 be right here. That doesn't really fit with the rest of the data either. 30,000, that seems maybe about right. Or 42. Okay, that's not even on the chart, so that certainly doesn't make sense. So it needs to be C. The scatter plot shows the number of minutes Richard studied and the scores in percent Richard earned on 5 algebra tests. What does the scatter plot imply about the relationship? Okay, so what does the scatter plot imply about the relationship between the number of minutes Richard studies and his test scores? The less Richard studies, the higher score he earns. Doesn't look like that. The longer Richard studies, the lower the score he earns. Don't think so. The longer Richard studies, the higher score he earns. Yeah, that kind of makes sense. And there is no relationship. I would say there is definitely a relationship. The more he studies, the higher he scores. Okay, and that's it. So that is scatter plots in a nutshell. Always remember, look at positive and negative to get rid of half of your answers. Line of best fit is just whatever line gets the most amount of points. Make sure you really read questions because this one had 2 parts. And this one you had to really understand it was since 1985. And I think these ones are pretty easy. I think you'll be fine. Let me know if you have questions.